Sample problem 6.12, sorting atomic radii. This is from OpenStax, problem set, I think chapter 6. Predict the order of increasing covalent radius. Covalent radius for germanium, Fl, bromine, and krypton. When you're talking about the size of an atom, in other words, the radius, it's pretty impossible to do that, especially when the best model we have is a model of probability. So you have a let's say like a point charge there. The nucleus is like just right in the center, and then you have like an electron cloud, right? Maybe this is your p, or let's just say it's an s orbital, right? So there's your like electron density. Maybe that's your 90% density cloud. But we know the electron can be out here, or so how do you measure something like that? So you got to come up with some arbitrary system. And one way we do this to get some consistent data is to use this covalent radius, which here I just copied and pasted this from OpenStax, where you have, when you have a diatomic molecule like fluorine here, F2, when they're covalently bonded like that, we can get the bond length, the distance between the two nuclei, and then we just take half of that. And if it's a non-metallic element that doesn't form diatomic compounds, then we can kind of estimate from all the other compounds that it forms. Interesting note is the numbers you get here using this method, this covalent radius, is much different from what you would get from the 90% atomic radius from the 90% density of the electron cloud. I'm kind of going off topic here. It's a good way, it's consistent, and so we're going to use that. And let's find this on the periodic table. Germanium is right there, number 32, bromine's number 35, krypton's number 36, all across the same period. Very nice. Fl is number 114. Tells you I need a new periodic table, but I like this one because it's just plain white and doesn't have all those colors to it. Let's take care of these. Well, what is the question here? Order, increase, smallest to largest, order by size. So let's take care of these. We know this is going to be the biggest, right? Because it's all the way down. Let's take care of these three, which are in the same period. And because they're in the same period, they're going to have the same number of shells, or the same number of energy levels. So here's n equals 1, n equals 2, n equals 3, which kind of also goes over here. Those are your 3D blocks. And then these all end in n equals 4. The valence electrons are for germanium. Germanium is going to end 4s2 and then 4p2 because it's the second element in this p block. Whoops, p block. Bromine is 4s2. 4p5 is the fifth element in that p block, and then krypton is going to have all its orbitals are full as 4s2, 4p6. And what I'm saying here is, maybe I didn't have to do all this. Their outermost electrons are all in the n equals 4. Let's do this down here. Germanium is going to have 1, 2, 3, 4 energy levels. And we know this is like, these electrons aren't out here. They can be clouds of probability, but 1, 2, 3, 4, and then krypton 1, 2, 3, 4. All right, so they all have 4 energy levels. Now, why did I draw germanium bigger than krypton? Because we know that it's going to come down to nuclear charge. There is the key. All right, see, nuclear charge, or the Z, effective, is what it's going to come down to, because they all have outer electrons in the, here's your 4s, 4p, and it's got a couple of them there. This one, let me just draw one. It's got a couple of them there, and they have different number of electrons, so that's not really the point. The point here is the 32 protons there are going to pull these in. Right, but that one, that guy on the outside is being shielded by all of these other electrons inside of it. This bromine is going to have 35 protons. So that's going to pull a little bit more because 35 protons is going to have more of an effective nuclear charge than 32. Right, but it's going to have the same shielding effect as germanium. And krypton, they all have this, they all feel the same shielding effect. Those electrons on the outside of all three of these elements are feeling the same amount of shielding from the electrons underneath it. But that electron on the outside of krypton is feeling a greater attraction toward the nucleus because krypton has 36 protons that are attracting it versus germanium, which is 32. So krypton is going to be smallest of these three, and germanium is going to be the largest of these three because of the difference in nuclear charge. And the shielding effect is going to be the same for all of them. There is our answer. Let me get a little more space. Krypton is your smallest one, and then bromine, and then germanium, and then Fl. And we know Fl is going to be the largest because it has, that's 7, right? 1, 4, n equals 5, n equals 6, that's 7. That's in the 7p. So I'm not drawing 7 rings or shells, but this is definitely the largest one, just simply because it has that many more energy levels. There's your answer.